Hello and welcome from the Ory office in Munich. So I want today to do a short interactive summary of our CTF that we organized for DevCon 30 last week. So essentially, this is kind of like a write-up, just a bit more of my thinking process and less of the formal approach on how to do stuff. So yeah, I guess let's jump right into it, and I'll encourage any one of you to just jump in and do the challenge yourself before you watch how it's done. And you can also just use this video for hints if you're stuck and want to continue. So we have hosted the challenge remotely for DevCon, but probably by the time you are seeing this video, it's not available anymore remote. So what you can do is just go to GitHub, clone the repository, and run it yourself because it's super easy. I'll quickly show you how it's done. Okay, so let's jump into it. So I have open here the project already, and I'll quickly explain how the repository looks. So we have a Docker Compose file that ties all the pieces together. You can have a slow look yourself, but it's not complex at all. We have here a configs directory. This holds the configs for Keto, Kratos, and Oathkeeper, which are the basic Ory components we're using to secure our backend. And then we have our application logic, the backend. This is a Go backend, and it lives here. It has a server-side UI rendering with Go templates. So it's nothing fancy. There is no NPM pipeline running that builds your whole UI, but instead, anyone should, without much prerequisite, understand what's going on. If you know a bit of programming in any language, it should be fine, I guess. Okay. Right, so let's just go ahead and start this up. So it's just Docker Compose up. This gets all the containers. It should also build the backend container for you if you don't have it yet. And yeah, now we're pretty much done. The whole thing started, and we can go to our browser and see how it looks like. So the port is localhost 5050. So yeah, you can just see a simple UI. This uses an email address and WebAuthn for logging in. So if you're, for example, on Mac, you can use Apple's built-in WebAuthn solution that should just be your fingerprint or device code. For anyone else, if you don't have anything like that built into your system or computer, what you can do is go and use Chrome instead of, I think only Chrome has this feature. In the DevTools, you can find the virtual WebAuthn keys, and that should make it possible for anyone to complete this challenge easily. So I have a YubiKey here, so I'll use that one because it's even easier than the simulated one. But it's not hard to simulate one either. Okay, so first look, we have a login screen. So let's have a look back in the code and see how that works. So if I have a look at the Docker Compose, because that's our entry point, right? We can first figure out where our traffic is going. So we see here there is the Keto service. Without knowing any special stuff about Keto, I mean, I'm the maintainer of Keto, so I know special stuff about Keto, but assuming I don't, what I can tell from the Docker Compose is there is a volume, that's the configs, there is an environment variable, which is just the credentials for the database. It's linked to the database, so this is network stuff. If you don't know, like the Docker specifics here. It's fairly easy to figure them out using Google. Then we have restart. That doesn't seem important at all. We have a entry point command. This one, entry point and command. This one seems interesting. We'll have a look at that later. And the image is just a normal Docker image from Docker Hub, so nothing fancy going on here. Okay, continuing, here we have Kratos. Again, image from Docker Hub, entry point. Now this doesn't have a dedicated script, so we can have a look at it right now. This is just running migrate SQL up. Seems like SQL migration, so creating tables and stuff with some flags, but they're probably not that important. And then Kratos serve, and this, I'd say, starts the server from a guess, educated guess. So nothing fancy going on here. Same with the restart on failure. Seems not important. We have the same link here to PG. So PG here, that's our Postgres instance. And yeah, environment variable, same thing. Volumes, same thing. The configs. So nothing fancy going on here, and the service is neither exposed to the outside network, basically. Then we have Authkeeper, also standard Docker Hub image. Command is just serve. There seem to be no migrations needed for this service. Restart makes sense. Links, now this is linked to Kratos and the backend. Sounds interesting. So this is somehow talking to multiple services and not to the database. And now here's the important part. We see here that the ports are exposed, and on our host machine it's 50-50, and on the container side it's some container port. So and we have the configs here again. So it seems that Authkeeper is handling the traffic, so as the first instance of things coming in. Here database, from a quick glance, nothing special, just some hard-coded secrets here, nothing secure, obviously, but for a local deployment and local tinkering seems reasonable, I'd say. And then here the backend, we have a build keyword here, or build key here. So this refers to this backend directory, and this backend directory has a Docker file, so that's what we're basically building. And then we have here links to Postgres and to Keto, but also no exposed port or anything. So all the traffic has to go through Authkeeper, basically. That's what we can tell from just inspecting the Docker Compose. Now, okay, let's further dig into what's going on. I said here that this thing sounds interesting, so we have here some entry point. Let's have a look at that part and how that works. We see it does migrate up. That's probably SQL stuff again. Here the comment even says database, migrate the database, start the server. Okay, that's good, I'd say. Now we see remove test data before deployment. Okay, this sounds fishy already. So there seem to be some test data, and it looks like they're just inserted in this service. Might come in handy, but I have no idea yet what this means and what we can do with this. So yeah, let's investigate further. So if Authkeeper is our main entry point, let's have a look at what Authkeeper does. And you could either just Google it, or I can tell you because I by chance know what Authkeeper does. So it's basically a API gateway and reverse proxy. And it's this is basically, this is the base config. And then there's some rules, and those rules are basically using here this matching strategy to figure out which route matches basically and which rule to apply. And for each request, the rule is just selected the correct one, and then some stuff is done, and then it's either forwarded or not, depending on what we determined. So let's dig into this a bit further and start with the root config. This doesn't seem interesting. Now we have authenticators. Authenticators no op is enabled, so no op means no operation. And this is basically just a authenticator that does nothing but just authenticate someone without checking anything really. So this could be used for public routes and stuff. All of these are things you would probably figure out by reading the documentation, and I can just tell you what it does because by chance I know this stuff already. Then we have the cookie session. This is basically a kind of authenticator that looks at the cookies that are sent in the request. Here, same thing, it's enabled, so we know it can be used. And it has some config. Here it seems the cluster internal MTLS is not really set up yet, but should be set up in the long run. So that's something probably the authors will still do once this should be deployed to production and not just be a local thing to host your CTF. And then the cookie session config has the check session URL. So that's basically where Authkeeper sends the stuff to check the cookie session. And this is a endpoint of Kratos that basically the sessions who am I endpoint, and that basically just takes the session cookie, looks up the session associated with it, and if it's a valid session, it will return all the session data. And then this is just to preserve the path of this URL. And then here we have subject from and extra from, and this is some Authkeeper internal stuff, and this basically tells Authkeeper where to look in the response from the whoami call and to see to figure out the subject and the extra. And the subject is in Authkeeper just a variable that's used for authentication and authorization. So the authenticator gives you the subject, and the authorizer will use the subject to query rules basically. Now here we see it's the key is, this is the JSON key basically, it is identity.id. So that's basically just what's in the response from the whoami call is basically the ID of the identity, and then we have extra, and this is basically just extra information we might use later on as we wish, and those are taken from identity traits. You will later see how the subject and extra can be used. Okay, then here we see authorizers. There's just allow enabled, so basically the only authorizer we have is allow, which basically does nothing. Seems interesting. And then we have mutators, and mutators are basically just a way to mutate the request before sending it on to the next service, like to the upstream service that's defined in the rule. And the mutators we have enabled are no op, so again, no operation, doing nothing, no mutation, just forwarded. So that's this part. And then we have the header mutator, and this, as the name suggests, adds or changes the HTTP headers of the request. This is enabled, and here we see the headers that are being set, and we see we have an x-user header, and now this is where the subject and extra comes in again. So the x-user header holds the subject, and the subject is, as we see here, the identity ID we get from Kratos. And then we can have a look further. There's also the username, which is the extra.name. So this is basically identity.traits.name. So this will be here in the x-username header, and then we have the x-user email header, and that's the email. Okay, so far so good, I'd say. Further, we have a arrow handler, or just arrow handlers in general, and the one we have enabled here is the redirect, and it redirects to /login. So obviously, if this is used, it will redirect, and an error is encountered. Authkeeper will redirect to /login. Okay, then further we have here the serve config. So this is basically enabling cores and nothing fancy going on here. And then here we have the access rules, and the repository of that is basically just the path where the access rules can be found. And then matching strategies says we're using regex. There is different options, but regex makes probably most sense to most people. So yeah, that's that part. Now let's have a look at the rules specifically. Here we see we have the first one as the public backend. It's called public backend. So it seems this should have the public routes of the backend. And as we see, the upstream URL is the backend. And the matching strategy is this regex. It's either HTTP or HTTPS. This seems like any host name on the first glance. And then we see it matches the login, register, error, leaderboard, and static, including subdirectories, paths. So nothing fancy, I guess. Login and register seem like suitable public routes. Error as well, just a generic error screen. Leaderboard seems interesting, so let's have a look on how that looks. So we can just here change our path, and then we see here the CTF leaderboard. We see total 0 submissions, and once there should be a submission, we should see a user ID and we should see the submission time. So let's hope we'll show up in a few minutes here on that leaderboard. Okay, going back to our code here, or to the access route specifically, what we see is that for these public routes or public seeming routes, we have an authenticator that's no op, so there's no authentication happening. Authorizer allows, so we were just allowed to proceed. And mutators is no op, so it's basically just forwarded. There's nothing happening here. So let's have a look at the next one. That's public Kratos. Upstream is Kratos, probably public stuff, right? So, and URL, again, nothing fancy here. And then all the self-service paths, and then the sessions for MI path and the well-known paths. So nothing fancy here. I mean, if you don't really know what's the paths of Kratos at this point, you might want to look up all of these, but we can have a quick look at the sessions for MI endpoint and see what that one gives us. So if we just copy that over here, we see we got an error message unauthorized, and this obviously is because no valid session could be found. So we don't have a cookie, so we get an error. So I suggest we should maybe sign up and see instead what we get if we're signed up properly. So let's go to the register page. And here it prompts us to input our email. So this one is my email here, and then my name is Patrick, and then I'll register using my And now Firefox grants me to add the key, and here we're logged in. That was easy. So here we can see current result is nothing, so nothing was submitted yet. And I mean, as this CTF resembles, or this backend resembles a election vote counter backend, the results we would see here are election results that were submitted, right? So we see here we can submit new results. That seems interesting. So let's just type some stuff in and see what it does. So I'll just hit the keyboard and input some random data here, and then we submit that, and as a response we get forbidden and not allowed. So basically we don't have permission to do this. Okay, interesting. So we'll have a look later in the code on what permission is needed to do this thing. Then the next section is, this one seems interesting. It says grant permissions to other users. So this means I can modify permissions in the system somehow, which seems like a very nice feature for a hacker, right? So if there's some problem with this feature, I might do some privilege escalation and get privileges I'm not supposed to, or give it to someone else and for some other account, right? Okay, and then here we just have a form to submit a flag. And yeah, we don't have a flag yet, so we can have a look here. So there seems to be a flag endpoint, and this also says forbidden, sorry, no flag for you. So we first have to do some stuff to get the flag right. Okay. The thing I wanted to show you was the sessions schema endpoint. And now we see we got some data. I'll enlarge the font size a bit. So basically here we see ID, which is the session ID. We see some expires at, authenticated at, authentication assurance level. Doesn't seem very interesting here. We see the authentication method as web authn, yeah, as expected. And then here we see identity and ID. And this is basically the stuff that we take as a subject in Authkeeper. So now we know where that comes from. And then here we see the traits, and that's name Patrick and email my email address. So essentially what you can see here is, yeah, just the basic stuff we put in before already. So yeah, that's interesting to see, I guess. And then let's maybe jump back to our authentication rules, because we didn't have a look at all of them yet. So this one was not very interesting, as it was also just doing nothing, just forwarding basically. So let's see, this one seems more interesting. So we have an auth-only rule. And this is for our backend. And now this is matching the paths /, so the root, so just the dashboard we have seen before, and results, and grant access, and the flag. So it seems that this is somehow related to getting the flag and giving access to someone. So basically all of these are somehow protected, and let's have a look at how they're protected. We see here we have the authenticator, which is the cookie session. So that's the stuff we configured before. So we know, okay, it's looking at the cookie session with Kratos, and just, yeah, gives you a response of that. Then we have authorizer is allow. Okay, so there is no specific authorization happening at this point, but there seems to be one at a later point because we still got a forbidden response on the flag and the results submission. And then the mutator is the header mutator, and this basically adds our name, email address, and identity ID. So yeah. And we can also see here that in case of an error, we get redirected. So this redirects to login, if I recall correctly. Yes, exactly. Okay, so in case we're basically this will probably only fail if we don't have a session, and then it redirects us to login, which totally makes sense, I guess, because then we can log in and then we do have a session and then we can continue. All right. So now let's figure out how the endpoints are protected. And this is, by the way, a good chance and a good point to try all of this yourself and continue from here, because now you got a good overview of the basic structure, how everything is wired up and how it works together. Until this point, I don't think I gave away too much stuff that would be interesting for the CTF. But yeah, let's continue here. Okay, so we'll close those config files because we're not interested in them right now. And let's have a look at the backend code. So main seems like the main entry point. Let's start here. Okay, we see it reads the config. It creates a new repo, whatever a repo is. It creates a new handler. That's probably an HTTP handler. Yes, as we can see in the return type, it gives us an HTTP handler. And then it starts a server, and then it listens and serves. Okay, fair enough. That seems reasonable and is not too much stuff. So yeah, we can see here the repo, whatever that is, it is somehow passed to the handler. So it's a dependency of the handler, and the config in turn is a dependency of the repo. So let's maybe first have a look at the handler and see how the handler works. This somehow doesn't have my dependencies. So let's quickly get the dependencies, and once that's done, it should look pretty in the editor. Okay, nice. So basically we can see a new handler takes the repo and the config. Repo, here we see SQL repo, so that seems like our SQL persistent layer. So that's what we'll be talking to the database probably. Okay, so here we see we set up a Keto read gRPC connection. This is, if you don't know what gRPC is, look it up. It's pretty nice. But for simplicity's sake, it's basically just a connection to Keto, and it seems to connect to Keto on this port. And then we have also a Keto write connection, which also connects to Keto, but on a different port. So yeah, that seems reasonable. We set up the connections first, nothing happening really here. It's just setting up the dependencies. Then we create a new HTTP router. So that's probably used to figure out which route to serve and stuff. And then here we have the handler struct, and this basically just holds all the dependencies. Also here creates some new ones to have a JSON and text writers. So that's probably some convenience functions we don't really have to look into. And then here we can see a new API client being created. And if we look up what this package does and this API client does. It's basically a client for Kratos. So this is a way for us to connect to Kratos. So now we know the backend can talk to Keto and Kratos and has the clients and connections set up for that. Same here. We see we instantiate a check service client and a write service client using the previously created gRPC connections. Okay, now this is just bundling all the dependencies we have. R is, if we jump back, the HTTP router. So this is basically just all the routes the backend is serving, and we can have a look at all of them. Login, register, error, those are public pages. If we have a look in the Authkeeper rules again, and those are basically just served here. Now we have here a kind of middleware that's called required flow. And this looks up if the URL query has a key called flow. And if it does have one, it just continues. And if it doesn't, it redirects to self-service flow, which if we go back here is login in the first case and registration in the second case. And I can tell you, for your magic, not having to read the docs, that this basically just initiates a new flow with Kratos, and Kratos will then redirect back to the login or registration UI and just, initiates all of the stuff that's needed for logging in or registering. So this is nothing really fancy here. So it seems that only with a flow parameter we can go to login or registration. So let's get back to this part. This is used here. Error is just exposed as this. Then the index page is also exposed as this. Then we have a post route on results, and this allows us to submit results, it seems. So we'll have a quick look. This is a small helper that just gets a count and parses the string to uint, so unsigned int, from a given query name, or in this case form name. So we can see it's used here for creating the result struct, basically by reading in all of the information that were submitted in the form. Okay, interesting. And now comes an interesting part. So we can see here we are doing a keto check. And this keto check basically, just seems to check permissions with keto. And we can here see what permissions we check. So we check, basically what we check is whether the subject, so that's, as we can see here, the X user header, has the relation submit on the object district. So basically the thing we submitted here, this one. Okay, so it basically just checks whether we have a submit relation. And if we have that one, so X minus user here, that's the user ID, if we look it up again. And basically if we have one, then we can submit, and if we don't, so if an error occurs, this is basically connection errors. So if an error occurs, we just get the error message transparently back. And if it is not allowed, then we get a forbidden error. That's the one we've seen before. And if it is allowed, so basically not returning this return statement, then it seems that we submit that stuff to the repo, which is the SQL persistence layer. So that's then persisted to the database. Again, some error handling here. This is in Go maybe not familiar for everyone. This is very explicit and not like many implicit error handling things like exceptions in other languages. So if everything succeeds, we come to this point where we just write created. So this gives us a confirmation that our submission was accepted. Okay. So far, so good. Now, there doesn't seem to be any way to circumvent this check. We do have some input parsing on our side, but in case some error occurs, this will just be 0, and we have no way to change the control flow of any of the function here. Also, the error handling, all of this is done properly. There is no missing return, so assuming this return wouldn't be here, then after the error is written, the code would still continue. But as we see, all of the returns are here. So this is not what's happening. So there's not really a way, at least an easy to spot way to circumvent this part. Okay, then let's go back to all of our routes and have a look at the rest. So the grant access one. Now this one, as I said, looks pretty interesting because what it allows us to do is grant access to some user, which might be either me or a friend of mine. So what I could do is, in case there would be some vulnerability, get access that I'm not supposed to, which is called privilege escalation. Okay, so let's have a look at how this function works and what it does. So we get sub, real, space, and object. So this, as I'm very familiar with Keto, is just, yeah, we can see here, subject, relation, namespace, object. That's basically a Keto relation tuple. So that's stuff that we obviously submit through a HTML form. So that's the stuff we can submit on that page. Now let's continue. So there is some check happening here. The result is called self. And what this does is it basically takes the namespace, object, and relation, and it checks whether the user who's doing the request is allowed to do this thing. And then it basically has error handling here. And if it is not allowed, then it's a forbidden error. And if it is allowed, so the user is allowed to do this operation they're granting someone else to do. If they're allowed to do it themselves, then it seems, now this is inserted, so it's basically the same thing, but with the subject. So that's basically just creating the permission for the user. Okay, so let's have a look if there is some flaw in this whole flow, if we can somehow circumvent the first check or manipulate some stuff. Okay, the user inputs we have control of here are subject, relation, namespace, and object. So these are things in the form, and what they do is they're passed down here, but the subject is taken from the header. So at this point, we can control these things, but this one not, because this one comes from Oathkeeper, right? But wait a second. If we take a closer look, then we can see that here the header that we take is the x-username header. Okay, let's have a look again and confirm. So the x-username header in Oathkeeper is the extra name. So the identity traits name. So, and if we check and have a look with the previous one, what here was used as a subject is the x-user header. So it seems there is some kind of subject confusion happening. Now I wonder if we can somehow use that, because the username is input that we can provide while creating our account, right? We can just put any name there and we can then see, we can then create and control this input. Okay, that's a very interesting observation here. So basically what we can do is control all the inputs at this point, and none of this input is forced by Oathkeeper. I mean, it is forced in the request, but we have a way to control each and every part of this. So all we have to do is get the right stuff here and then get a true response, so a allowed response, which then allows us to basically grant the same permission but with a different subject. And now if we can get this subject to be the user ID of either us or someone else, this means we can basically here input some user ID that has the permission already, and then we can give it to someone else or to us. So this seems handy. So this would allow us, if we had some way to figure out basically how to get a proper let's have a look here again. So here is the check that's happening. So here the namespace, object and relation, that stuff we can easily control. That's just form inputs. And the subject is here the user, which is the user ID, and we cannot control our own user ID because that's assigned. But what we can control is the username, and the username is what is used at this point. So this should allow us to sign up with the username, which is the ID of someone else who already has that permission, and then grant that permission to ourselves. Okay, so I suggest let's try that. Let's go back to our browser and basically go to, So we want to, we are already signed in and we want to, there's no sign out button. So this is bad UX obviously, but what we can do as hackers is just go into DevTools and then here here under storage, we can see our cookies, and here we can see the Ory session. So that's our session token. Let's just delete it, reload the page. And yes, now we're on the login screen again. Hacked it. So let's go to the registration. Right, and now here we can see we have the name input, and here we can just put a random text. So that's the text, or that's where we want to put a user ID. Now I forgot to take note of my user ID, so let's log in again as the user we had previously. And right, so this now prompts us to use the WebAuthn key we used previously. And what we'll do is take note of the user ID that we have here. And now we can do the magic logout stuff again. So delete that cookie and then reload the page. And then we can register. Now we need some other email address, obviously. Wait, let's take one that we remember. So ctf@ory.sh. And then as a name, we want to put our user ID. So let's paste that in here and register. We can use the same web.end key here because we have a different identifier, and now we're logged in. So far, so good. Okay, let's try to invite ourselves to the party. Okay, so as we now see, our name, which was previously here, is the ID of the other identity, and our ID here is behind that. So let's try to grant this one access to right, but that identity didn't have any permissions, so we can only grant the same permissions, and it didn't have any permissions, right? So let's figure out which identity to use. I do remember on the leaderboard it said something about identity ID, right? So yeah, this has user ID. So we could theoretically use the user ID of someone here, but there is none. Okay, let's have a look again and just comment this part out so we have a nice arrow. And then yeah, so one strategy we can use is we can search we can use some free text search to see. But if we remember correctly, then you will figure out there is this key to entry point thing. And this one has removed test data. So this one has the test data it shouldn't have, right? And yeah, what we can see here is some permissions and a user ID as the subject. So this means we know now the ID of someone who has some permissions. And interestingly enough, we have namespace, district, object testing, relation, submit, and the subject ID. And this subject also has the permission flags, new flag create. So suppose with this we can create a new flag, right? So let's try this out. This is now the ID we want to use as our username. So let's go back to the browser, log out. And now we have to register, and as the email, now we use ctf+1. And the name is that other ID. So let's try this part. Now, we can use the same account here. So what we have here is our own ID. That's pretty handy. So let's try to paste all of that into the form. So it's this ID, and then I'll copy over just the stuff. So relation is submit, right? Namespace is district, and object is testing. So in theory, this should be possible now to grant us the permissions because our username is the ID of someone who has that permission already. And that's what's used for the permission check wrongly. Obviously, this is a bug and not meant to be. Okay, done. Nice. So let's get back to the dashboard and try to now do that submission. So the district was testing. Whoops, we need some numbers here. Who else will get a error? Okay, no specific response. Does this mean it worked? Yeah, it did work. Okay, nice. So we now had a submission, and it seems like we can do the same thing with the flag. So let's try again. So let's give ourselves the permission to get a new flag. Let's just verify that we don't have a flag permission yet. So localhost 5050 flag. Now this says forbidden, no flag for you. Okay, let's try and give us the permission to get a flag. Okay, it seems like we need... So we can have a look in the code again to see what's the permission, but I suppose it is the one we see here. But we can quickly verify that one. So let's go to the flag handler that seems to give us a flag, as the name suggests. So encode flag creates one. Decode flag decodes it again. And then get flag is that's the handler of the route. So what we can do is have a look at how this works. Okay, this gets the user, which is the x minus user, so it's the ID, so that's the right subject to look for. And then we do a permission check with Keto, and this is checking the namespace flags, object new flag, and then relation create. So do we have that permission basically? And it uses this username. Okay, so let's confirm. Yeah, that's what this permission is also. So this identity also has the flag permission. So let's use that and give ourselves the permission to create a flag. Okay, no typo in there. Okay, we got the access. This now should mean we should get a flag. Okay, nice. Awesome. So now we here have our flag, and on the dashboard we had some way to submit a flag, right? If I remember correctly. So this is the flag we got, and this is the email. So it seems like someone was very nice and allowed the use of test emails before, so that you can here then change your email to whatever you want to. So even if you used a fake email before, you could still change it at this point, and then you submit it. And that's how you complete the challenge. So thanks everyone for looking into this, and I hope everyone enjoyed the challenge. If not, please let me know why. If you did enjoy it even more, just let me know why. Comment on this video or open an issue in the repository, and yeah, just give me a heads up how you did it. If you had some other approach and maybe used a leaderboard instead, or if you generally found something completely different. And obviously, if you did take a look into the open source projects and found a vulnerability there that allowed you to get the flag, which definitely should not be the case, but in case you did that, head over to our bug bounty program on HackerOne, and that will give you a nice bounty to, depending on severity, but I guess if you got the flag, then it's a pretty severe one, and then you should get up to $3,000 as it is currently. And yeah, hope everyone enjoyed it, and hope this kind of interactive CTF write-up was interesting and you learned something on the way. So yeah, see you all soon, and have a nice day. Bye.